This is about the questions in the NCERT textbook. Hello students, today we are doing a second video on domain and range. If you want to know about the first one, the link will be in the description below regarding domain and range. The first one is from exercise 2.3 wherein you have to find the domain and range of minus of modulus x. So we know that modulus x is a standard function whose domain is all real numbers, because whatever number you take here, the function is defined, and the range is 0 to infinity, including 0 to infinity. So, whenever you take a modulus function, then this is the domain and the range. But now here they have given us minus modulus x. So, the domain will remain as it is, because even if you take any real number, minus of the value will exist. But the range now, because modulus x is greater than or equal to 0, so minus of modulus x will be less than or equal to 0, and so the range is all negative numbers and then including 0. Now we have to find the domain and range of root 9 minus x square. So first what we can do is we can factorize this, say 3 square minus x square. And put this critical points on the number line. What are the critical points? That values where this function is going to become 0. So if 3 minus x is 0, that is for 3, this function will become 0, and same way for minus 3. So these are the critical points. Now take a number in any of this divided part of the real numbers or the partition of the real numbers. Whenever you put critical points on the number line, you will get different partitions. Here we have 3 partitions. So we can take a value in any of this. Say if you take the number 0, which lies in between this. So this is positive, substitute 0 and c, and put a number greater than 3, say 4, you will get negative, and same way over here. So since in square root we do not want negative numbers, that is why our domain here is now all numbers beginning from minus 3 to 3, because we can include minus 3 and 3 since a function can be 0, root of 0 is defined, but root of negative numbers is not defined, so you cannot take this part of the domain. Now for the range, in such questions we can equate it to y, which we assume is the image of the function. Now as you can see, this is given as root of 9 minus x square, meaning only positive values are to be taken. So we take maybe 0, so non-negative values can be included. We will square both the sides. Now you are looking for those values where x will become undefined. So taking square root, and because now you are taking square root of x square, taking square root on both the sides, you have to write plus or minus. Like for example, square root of x square is equal to 4. If x square is 4, then square root of that will be plus minus 2, because minus 2 square will also give us 4 and 2 square will also give us 4. But if the question would be x is root 4, then we would write only 2, because it's specified that you have to take only positive value. That's what we have done here. It's already specified we have to take only positive value. That's why we have taken y greater than or equal to 0. But over here, it is not so. That's why we have taken plus and minus both. And as such also we know that x values are any positive or negative numbers lying in this interval. Okay, so go back to this, and it's similar to the domain kind of function. So let's again factorize this and put down the critical points on the number line. It's going to be similar like the domain. Only thing here we are looking for image values. So it's minus, plus and minus. All these values are good, but over here we have decided that y should be greater than or equal to 0, and that reduces our range to 0, 3. So that's the range of the function. So now to the miscellaneous exercise. In this exercise, the third question is about finding the domain of this function. Whenever you have a rational function, then the domain is defined as all those values where denominator is non-zero. So let's first find out when is the denominator 0, and because this is a quadratic equation, we will simplify to find out the roots. And on factorization, splitting the middle term, you will get minus 6x and minus 2, and so the factors are x minus 6 and x minus 2, giving x values to be 6 and 2. Those are the critical points, or those are the values where this function is going to have the denominator as 0. So the domain will be all real numbers except this 6 and 2. And you can write it in any order. You may write 2 comma 6 also. In the fourth question, we have to find the domain and range of this function. So once again, because it is a root value, we do not want the numbers in square root as negative. So we are looking for non-negative numbers. Find out the critical point. Just putting x minus 1 equal to 0, that means x equal to 1 is the critical point. Critical point again means that when is a function going to be 0. So over here we put 1 on the number line gets divided into 2 parts, and look for that part which will be non-negative, okay, or positive, because 1 is to be included. If you include 1, then the function will be 0. Okay, so if I substitute a number greater than 1, say 2 minus 1, instead of x I am going to write 2. It is positive, that means this part is positive, this is negative, and in square root positive numbers are allowed, and that's why the domain is 1 to infinity, all numbers beginning from 1. So all non-negative numbers are allowed here. Now for the range, we need that, or we'll equate this to the image y. This is the image. So squaring with the sides, and you have x is 1 plus y square. Now when is this function not going to be, or when is this value not going to be defined? For all y values, 1 plus y square will always be defined, whether you take negative, whether you take fraction, whatever. It is not having, when you have to think, when it is a square root value, or when you have the term in the denominator or something like that, or when it is modulus integer part. This is a simple quadratic expression, 1 plus y square. So this is never going to create a problem, or x value will always be defined for whatever y you take, and that is why for all real numbers this is good. So from here we can say that y can be any real number, but as discussed in the previous question, because it is given positive root, we should have y to be greater than or equal to 0, and that's why our range turns out to be 0 to infinity. Again a domain range question with fx is equal to modulus x minus 1, and modulus function is, we know that the domain is real number and the range is 0 to infinity. All non-negative values will be your image. Now over here there is nothing else, like there is no minus sign before the modulus value. It is not 1 upon modulus, nothing like that. So it will be the standard domain and range of a modulus function. Whatever value x minus 1, x plus 1, anything over here within the modulus sign will give you the same domain and the range. So this is a pretty easy question. So question number 6 in the textbook is asking us to find the range of this function. Already we are given that this is a function from R to R. That means the domain is R. This is the domain, this is the image. This is the pre-image value, this is the image value. Like if you write this as fx equal to form, it will turn out to be f of x is x square upon 1 plus x square. This is our image which we are supposed to find. What is the range from here? Okay. So to find the image, we always need to convert the function. To find the image, we always need to convert the function in the form of x equal to. So let's simplify this and bring x on one side. So we have x square minus yx square, and taking x common, you have 1 minus y, which I will take on the other side, and so x is plus minus So like that earlier question where we had 3 minus x and 3 plus x in the square root, same way over here we are having two factors, y and 1 minus y. The only thing over here is that 1 minus y cannot be 0. So we'll put it down here, 1 minus y is not 0 and that means y cannot be 1. Besides this condition, we also want this to be together to be positive. So either both of them can be negative or both can be positive. But the easiest way is to put them on the number line, and so I'll put it on the number line. What are the critical points? From here y is 0 and from here y is 1, and look for those values where this is going to give you a positive root value. Okay, so let's say that if you take a number greater than 1, because this number line is now divided in 3 parts, take value bigger than 1, say 2. So if I put 2 over here, I have 2 upon 1 minus 2, which is negative. So this is negative. Put a value between 0 and 1 and check, you will get it to be positive. So we are good with this value. But according to the earlier condition, again, 1 cannot be allowed. So the range becomes closed open interval 0, 1. So these were the questions from the textbook. I hope you understood the topic. Thank you. See you again in the next video.